Alright, we are going to be working on solving systems of equations by elimination using part 2. And you'll have to remind me to tell you guys a little story when I get back. Kind of humorous, especially to me right now, but I'll just tell you that I recorded this already, and well, this is deja vu for me. So, anyway, here's our lesson. We are going to solve a system of linear equations algebraically. It should say equations plural, but we're going to use elimination to find an exact solution. Also, we should be able to write the system of equations that best models the problem. And just kind of similar to what we did yesterday, we did have a word problem yesterday. This isn't necessarily going to apply as much today because we're not using a word problem, but we still need to be able to interpret the solutions in the context of the situation and decide if the solution is reasonable. So again, kind of like what I told you yesterday, if your solution is bigger than 10, like 11 or higher, then you probably need to check your work. So just looking back at the term elimination, remember that it's the act of removing something, so getting rid of. In our case, we're getting rid of a variable. And with the elimination method, it's best applied when we have our equations which begin in standard form. So that's what we're going to be looking at. Also, one other concept that we need to keep in mind is that with elimination, we need to get a zero pair. So like how we have this when we have this 3x minus 3x, it must be a zero pair where you have something that cancels out. If you have a negative and a negative, then you're going to have to maybe multiply one equation so that your negative 4y and your negative 4y now can line up differently to make one negative and the other positive. But we'll be looking at that. So anyway, let's take a look at our first example. Now, if we are trying to eliminate and we see that we have a 4x and a negative 8x, we look at the y's and we have 2y and 6y. Well, between these, here's one term that we are going to refer to that maybe you haven't heard in math in a while. LCM, and that's an abbreviation. That stands for least common multiple. The idea is that with our least common multiple, or as I said, LCM, whether you want to look at it or not, we're going to be checking out what is the smallest number that both coefficients multiply into. So if we're looking at the 4 and 8, essentially, 4 does indeed multiply into 8, which is kind of nice. So we're looking at an LCM of 8 for the x's versus if you're looking at the LCM for the y's, well, 2 does multiply into 6. So we're looking at 6 if we're trying to eliminate y. Okay, but since we have x where one of your coefficients is already negative, then it may be of substance or just beneficial to take the top and just multiply that. So let's try eliminating x this round. And if you guys wanted to, we could go back and try eliminating y, because that's equally valuable. So if we take the top and multiply it by 2 and just double it, then we will have, let's see, this gives us 8x plus 4y equals 20. And then with the bottom, we have still the same equation, negative 8x plus 6y equals 10. Okay, now when we line these up, notice how now what we originally had as 4x and negative 8x, those were not a zero pair. Nothing canceled, but the way we set this up now, we have 8x and negative 8x. Those would indeed eliminate. Great, so we're good to go. Now let's continue solving. We have 4y plus 6y. We get 10y equals 30. So we solve. Let's solve. We may divide by 10. We can drop the coefficients when they cancel, and we get y equals 3. All right, cool. Got our first coordinate. Now let's track back and find x. Now as we look at the top two equations, we have 4x plus 2y equals 10, which those are all positive. And then looking at the bottom one, you could plug in y into either of them. But I would say it may be easier just to plug in y to the top. So using the top, I'm going to say 4x plus, now we have 2, and we're going to put, instead of y, I'll put parentheses 3, plugging in the 3, and that's equal to 10. So, going through and solving, 4x plus, that simplifies to 6, equals 10. And then now just solving backwards, we would subtract 6 from both sides. 4x equals 4. And then when we divide, we get x equals 1. Alright. And we have our first answer. The solution is 1, 3. And remember to keep it in parentheses. That's your solution. Alright. Nice work, crew. Ready to keep solving. Okay, number 2. Wow, we got a bunch of negatives, but that's okay. We can handle it. So looking at these, we could take, this time I want to try eliminating y. It doesn't matter because you see we have negative 2x and negative x, which let's just take a second and think about what's the coefficient for either a negative x or a negative y. Right, those are negative 1x or negative 1y. So let's try eliminating y, just for the sake of getting that practice in. Well, as we look at it, we can take the top equation and multiply that. We already have a negative 5 down below. So let's multiply not just by 5, but let's multiply by negative 5. So that since we do presently have same signs, we don't want them to add. We want them to subtract, thus the negative. So we multiply the negative 5 through. We're multiplying 5 and then just switching signs. So you'll see we have negative 5 times negative 2 is 10x. And behind that we get plus 5y. And that's equal to negative 45. Okay. And then the bottom, actually that equation will stay the same. We have negative, should you want to put the 1 in, that's okay. We don't really need to, but again, it's all about what's going to help you to get the answer right. Know what I mean? Okay, so we have, here, let me kind of fix that 7. We have our two equations, got them lined up, and it appears that one of our variables is ready to eliminate. So, not the x's though. We subtract with those. We have 9x. The 5y's cancel. So 9x is equal to, subtracting in the back, we have negative, now that looks like 18, negative 18. 9x equals negative 18. Cool. One step to solve. Let's go. Divide by 9, and we get x equals negative 2. Boom. One part out of the way. Almost there. So, now looking at this, I noticed that we do have a bunch of negatives. What I would say, when we did this yesterday, I'd say let's try using that 10x plus 5. The one that we, here, going back here, 10x plus 5y equals negative 45. That looks good. And you have two positive variables. Let's plug into that one. So we'll take 10, and since we found x, got to put parentheses negative 2 back in. We have plus 5y, and that's going to be equal to negative 45. All right. Look good? Good. And by the way, I always try not to make a mistake, but you guys know I'm human. I'm not perfect. If you do spot something, just make sure to identify it for the crew, and I talk about mistakes and I make one. But yeah, just make sure you identify it. I'm not trying to teach you guys any errors. Okay, so 10 times negative 2, simplify, we get negative 20 plus 5y is equal to negative 45. Let's keep solving. Add 20. Set those cancel. We get 5y equals negative 25. Divide by 5. And we find out that y is negative 5. Alright. Cool. We have coordinate 1, coordinate 2. Let's put them in order and find our solution. Negative 2, negative 5. We're going to start making some math, algebraic video games where people, in order to unlock some kind of level, you guys have to solve a system of equations problem. And that's just the first level. Oh, goodness. I might actually create that. Okay. Ready for the next one. Now, before we advance, we want to notice how in the first problem, we multiplied just one equation, and here we've only multiplied one equation. But all easy things can eventually seem a little tougher. I don't want to say it that way. That sounds bad. But we've been multiplying just one equation. Now we're going to try something new. You may guess, yeah, we're going to multiply two equations. Good guess. Well, check this out. So, going back to that term we used previously, LCM, the least common multiple. Now here's the thing. 2, I can't, even though I can double 2, if I take 2 times 2, that's 4. That's way too big to go into 3. And we know, even if we can't fit 3 into 2. So the only thing that we can do to actually eliminate an x would be to multiply one equation and multiply another equation. Now we could also, because I think this may be one of the lowest, and by the way, one of the easy things is just to look at the two numbers And when in doubt, you could just multiply the two. So like the least common multiple for this actually is indeed 6, because 2 and 3 don't share any factors. Neither do, so we have 6 here versus, if you take 3 times 5, the least common multiple for that is 15. That's not that bad, and actually, since I already taught this lesson about half an hour ago, I think I want to try eliminating with y this round, just so we can continue getting practice with it. But let's do it. So I see that we have 5 on top and 3 down below. Let's take the top and multiply that by 3, and we'll multiply the bottom equation by -5. Why -5? That's the question. Because, see, the thing is, if I take 3 times 5, what do we get? Just looking on the side, we get 15. What about -5 times +3? We get -15. Always keep in mind, with elimination, we need to be thinking in the realm of how do we eliminate a variable, or how do we eliminate something, and you got to get a 0 pair. So let's get rid of that stuff. Okay, so multiply through, we're going to get, and let's just bring this stuff down. The top equation is going to be in purple. So we have -6x plus 15y equals -45. Now the bottom, multiply everything by a factor of -5, so just switch your signs when you multiply everything by 5. Get -15x minus 15y, and that's equal to, -5 times 12. Let's see how our multiples are. -60. Cool. Now we've multiplied through both of the equations, and it looks like we're ready to solve. So we see the x's, those don't eliminate this time. That's good, because we were trying to eliminate the y's. And -15y and +15y, sorry, backwards. Those are a 0 pair, they eliminate. So when we simplify, we have -21x equals, adding these together, we get -105. So -21x equals -105. And let's keep solving. If we divide -21 from both sides, they cancel on the left, and we get x equals, now we know that the negatives cancel. How many times does 2 divide from 10? Or how many times does 1 go into 5? Both of them should be the same answer, because your answer is 5. X equals 5. Okay, so we found our first coordinate. Now looking back at equation 1, equation 2, well, I actually like 3x plus 3y equals 12. That looks like one of the best to plug your x back into. Since everything's positive, let's do it. Okay, so we have 3, remember we're plugging in 5 immediately, plus 3y, so 3 times 5 plus 3 times y, that's equal to 12. Okay, solve time. 15 plus 3y, whoa, that's an ugly 3 on my part. 3y equals 12. 15's bigger than 12. Wonder why. Oh, because we get a negative. So, these cancel. We have 3y equals negative 3. And then when we solve, we divide by 3. Wouldn't you believe it? We get y equals negative 1. We have two coordinates here, x, y. They go together. What's our answer? 5, negative 1. Alright, cool. I don't know if any of you watch Modern Family. I'm not trying to sound like Phil Dunphy, but I wouldn't hate it if I did. Just saying. I guess that show's going through my mind. No problems there. Okay. Well, if you need to pause for any questions or just to look at the work and check and just make sure everything's good, yeah, go ahead. You're creating a work of art. Look at this. It's beautiful. All right, let's do number 4. Okay, number 4. Got our two equations. I'm looking at, let's check it out. We have 3 and negative 5 versus negative 7 and negative 6. Well, for the LCM, I think it looks like, okay, the least common multiple says that the least common multiple for the x's would be 15 versus 42 for the y's. No, thank you. Let's go with the x's. All right. And that means this time we'll take top equation multiplied by 5, and the bottom multiply that by, no, these signs are, the top is positive, the bottom is already negative. So that means just keep it, you don't ruin a good thing. Multiply the bottom by 3. I can't remember, because I already taught this lesson, if I identified it, but students will say, yeah, you just got to switch the coefficients. But again, remember, I didn't put a negative 5 up here for a big reason, because if I had a negative 5 up there, we'd get negative 15 and negative 15. And I'm sorry, negative 15 and negative 15 don't cancel, they double. So got to make sure your signs are opposite every time. Okay, so let's go through. We're going to write our two equations. Starting with the top, we have 15x minus 35y equals, negative, anybody ever counted with nickels throughout their life? 85. Multiples of 5, always good to practice. Multiples of anything are always good to practice. Who are you kidding? Okay, now we take the bottom equation, multiply everything by 3. We get negative 15x minus 18y equals negative 21. Why am I doing all the work here? Oh yeah, because you guys are on the other side of the screen. Okay, well, notice how all of these, as far as, let's see, looking at the variables, does anything cancel? It better. We just use elimination. Okay, we got the 15x's, those eliminate. Negative 35y and negative 18y, what's that give us? Oh, negative. Hey, mental math people out there, what do? I usually take something like 18. Because we're adding, I'm going to round it over to 20. So that negative 35, I just bump 20 over. We get negative 55, but then take 2 away. So that's actually negative 53y. Well, look at these math tricks we have out there. Double, and then just make sure to add the right-hand side. Get negative 106. Fancy! Hey, once again, we're going to be dividing. So if we divide by negative 53, you can do that mental math and just, okay, negative 53's coefficients cancel. And same with these negatives, but keep in mind 10 divided by 5 is 2. 6 divided by 3 is 2. So we know that y must be 2. Ho ho! Boom! First coordinate out of the way here. Okay, checking back at the problem. The lesser of two negatives. Right up top. 3x minus 7y equals negative 17. That has one less negative than the bottom. So we'll plug in 2 into that. For which letter? For y. Okay, we have 3x minus 7. And what is our y coordinate? Oh, 2. 7 times 2. And that's equal to negative 17. Okay, let's solve. That's going to be my math video game. It's called Let's Solve. It's going to be the cheapest video game out there. Because you got to sucker people into buying it, and then they have to upgrade every time they want to get to the next level. Just like any cell phone game. Okay, 3x minus 14 equals negative 17. If we add 14, those cancel, leaving us with 3x equals negative 3. And then let's do some division. That would be pretty awesome right there. We get x equals, what's the deal here? These 3's canceled. Hey, I'll take it. Got my answer. Know what I'm saying? Alright, what's our answer? It is negative 1, 2. Yes, it is. Answer locked in. Cool. Another answer in the books. We have one more example left. Almost there. Okay. Now, part of your assignment is also to find our victory song for after we finish an example. Last term, like I said, it was Everything is Awesome from Lego Movie. Maybe I might refer back to that, but you know, we got to keep our interests fresh and look into the future. So let's see what's new. Okay, last one. Question 5. Looking at the variables and considering the LCM, the least common multiple, I'm looking at 5 and 6 versus 7 and 10. Well, 5 and 6, those would multiply to be 30, versus if you take 7 and 10, those don't have anything in common. So the GCF, or sorry, wrong phrase is, well, anyway, they multiply and you get 70. So either way, it ends in a 0, but let's stick with the x's for now, because that's still just easier. Okay? Well, then we'll take the top equation and multiply by the missing factor of 6. And then the bottom equation, we'll multiply that by, let me do this in green. Now, as I'm thinking about it, some of you will be like, can I always multiply by the other number? Honestly, you can, but you gotta pay attention to the rule of signs. So that we know 6 times 5 and 5 times 6, well, they're not the same because one is negative. If they're opposite, then you're good. Okay, now, let's multiply through. In the top equation, what do we get? We have 30x minus 42y equals, 6 times 24. I know we have, what I do in my mind is I take 6 times 20 and 6 times 4. Now that's 120 plus 24, we get 144. Now, looking at the bottom, oh man, we have 5 times negative 6, we get negative 30x. 5 times negative 10y, Yep, you bet. We got negative 50y. And that is equal to 5 times 8. What is that? It is 40. Ho, 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 boy. Let's check that out now. Sorry. Multiplying through, we would get, well, don't forget, we're eliminating, so these x's cancel. Thank goodness. Okay. Now, with the y's, those look like they add together, so we get negative 92y. Because I said so. Okay, negative 92y. That is equal to 184. Alright, and hey, we're going to divide one step to solve this one. Divide by negative 92. Now the negative 92's, we know they cancel, and we're going to find out the value of y. But again, what I like to do, and you can see we have 18 divided by 9, or negative 9. Guess what? It is going to be a negative answer, but 18 divided by 9 is 2, and 4 divided by 2 is also 2. You can look at those factors, and it really does help. It helps to make it easier to solve without using a calculator. So we have y equals negative 2. Now, going back, looking at whichever equation we want, I'd say let's plug it into the top. So, and again, we're plugging in for y. So we have 5x minus 7, and we had negative 2. So negative 7 times negative 2, and that's equal to 24. Okay, let's solve. Yes, my video game coming to life. Okay, 5x plus 14 is equal to 24. Continuing on, we may subtract minus 14. What do we get? Those cancel. 5x equals 10. One step away. Let's do it. Divide by 5. And, oh, you know it. We got x equals 2. Yes. Got our solution. We just got to put it down. What do we have? 2, negative 2. Man, why don't we have celebration music right now? Because we just rocked this. Oh, man, that was awesome. Good work, crew. Would you look at that? That looks like a work of art right there. That is beautiful work. All right. You guys did great. Awesome as always. Keep on shining. And I guess if I'm looking at something that I'd recommend, please be really careful with integers. That's what trips people up on these and causes stress. Be very diligent. Now, even I make some mistakes sometimes. If you caught any that I didn't identify, I apologize. But I'll try and help with any questions that I can when I come back. Otherwise, you guys have a great time, and I will see you soon. Take care.